It's estimated that our galaxy, the Milky Way, has 100 to 400 billion stars. And when you hear a number like that, the obvious question is, are there civilizations on planets that are orbiting any of these stars? And maybe an even more interesting question is, can we detect any of those civilizations? Have they gotten to the level of technological progress, like us, that they're emitting electromagnetic waves into space that other civilizations like ours can detect them and say, hey, there's someone else out there watching television or using radio or whatever else they might be doing? And so what I want to do in this video is not answer that question. It's a big open question. We don't know the answer. We don't have anywhere near enough information to definitively answer that question. But I want to do is come up with a framework for at least thinking about that question, a way of actually estimating how many detectable civilizations there are in just our galaxy. And there's a formula that you may or may not have heard of called the Drake equation. And what we're going to do is independently derive our own version of the Drake equation. It's going to be slightly different, but it's the same thought process. And in a future video, I'm going to maybe reconcile what we come up with the Drake equation. And just so you know, the Drake equation is named for Frank Drake, who is a professor at University of California, Santa Cruz. He first kind of put some structure around this problem, and that's why the formula or the equation has his name. But the equation, it's not an equation that you can apply on a daily basis and give results that you can use to build things. But what it is it structures our thinking around this question of how many detectable civilizations are there in our galaxy. Now, to answer this question, I'm going to start a little bit differently than Frank Drake did. He starts with the number of new stars that are born each year. And we'll see that our definitions are actually pretty close to each other. What I want to do is start with the total number of stars. So what we're trying to come up with is, I'll call it n. And this is the number of detectable civilizations. Number of detectable civilizations in the Milky Way, in our galaxy. And once again, there could be civilizations. Looking back at this star field right over here. This star right over here, maybe it has a planet that's in the right place. It has liquid water. And maybe there's intelligent life on that planet. But they might not be detectable because they aren't technologically advanced enough that they're using electromagnetic radiation, or maybe they just figured out some other way to communicate, or maybe they're beyond using electromagnetic radiation, radio waves and all the rest to communicate, and so we'll never be able to detect them. We're talking about civilizations like ours that are, to some degree, using technology not too different than our own. So that's what we mean by detectable. So let's think about that a little bit. So I like to start with just the total number of stars in our solar system. So let's just start with, I'll call it n star and asterisk. And this is the number of stars. Number of stars in our, not in our solar system, number of stars in our galaxy. Number of stars in the galaxy. And our best guess, I said, is this is going to be 100 billion to 400 billion stars. We don't even know how many there are. Some of them are undetectable. In the center of our galaxy, it's just a big blur to us. And we don't even know what's on the other side of that. And we can't even see all the stars that are packed into the center. So this is our best guess: 100 billion to 400 billion stars. Now, obviously, it's going to be a subset of those stars that even have planets. So let's multiply it times that subset. So let's multiply it times the frequency of having a planet. If you're a star, this is the percent chance, or the frequency, or the fraction of these stars that have planets. So I'll write it this way: fraction that have planets. That have planets. That have planets. So if this is 100 billion, and that, let's say, I'm making a guess here, and we're learning more about this every day. There are all these discoveries of exoplanets, planets outside of our solar system. Maybe this is 1/4. Then we could say, well, that means that there are 100 billion times 1/4 means that there are 25 billion stars that have planets around them. But that's still not enough to go to civilizations. We also need to think about planets, because a planet could be a planet like Jupiter, and we don't know how life as we know it can survive on a planet like Jupiter or on Neptune or Mercury. It has to have planets that are good for sustaining life, preferably have a rocky core, liquid water on the outside. That's what we think are the ingredients that you need for life. Maybe we're just not being creative enough. That's what we know as life as being. So let's multiply this. Let's multiply this times the average number of life-sustaining or planets that could sustain life on them. So we don't necessarily that they're going to have life, but they seem like they're just the right distance from the star, not too hot, not too cold. They have the right amount of gravity, water, all the other stuff, and we still don't know exactly what this means. But this means average number. So given that there's a solar system with planets, what's the average number of planets that are capable of sustaining life? Average number of planets capable of sustaining life. Sustaining life. And once again, we don't know this answer. Maybe it's 0.1. It's kind of, it's probably less than 1. If for any given solar system that has planets, the average number capable of sustaining life, maybe it's 0.1. Maybe it's more than 1. I don't know. We don't know the exact answer here. But I'll throw an answer here. I'll throw out a guess. Maybe it is 0.1. And here, the fraction that have planets, I don't know. I'll throw that out as, and once again, I'm just making up these numbers. We really don't know the right answer. This is 1/4. But if we were to multiply this out, we would have the average number of planets in our solar system that are capable of sustaining life, that are around stars, that have planets, and these planets are capable of sustaining life. Now, and this would give us the total number, because this is average per solar system that has planets. This is the total number of solar systems with planets. You multiply it out, total number of planets in our galaxy capable of sustaining life. Now, just because you have liquid water and the right temperature and all of the rest ingredients doesn't necessarily mean that you will actually have life happening on your planet. So let's multiply that times the fraction that actually generate life. So this is the fraction that actually have life. And this is actually a very, we don't know this answer. So this is the fraction that have life on them. Have life. And this is a really big open question. Maybe if you have the ingredients, maybe almost every planet has life. Maybe it's a frequent thing that's happening in our galaxy and, frankly, our universe. Or maybe it's a very infrequent thing. Maybe it's just the right kind of freak set of circumstances that just have to happen. I'll throw out a number just for the sake of just to have a number there. Maybe it's 1 out of every 10 planets that have all of the right ingredients for life actually do generate life. My personal guess is probably higher than that, given that life seems such a robust and flexible thing that we've been seeing in all sorts of weird circumstances. Actually, let me make it even a higher number than that. So let me make it 1/2, assuming that we have all of the ingredients. So this should tell us essentially how many planets, if we were to multiply all of these, how many planets in our galaxy have had life on them at some point in those planets' lives. The life might have come and gone. It maybe destroyed itself through nuclear war or whatever. But this would tell us the number of kind of life planets in our galaxy that have had life on them at least one point in their history. Now, we care about civilizations. So let's multiply this times, if you make all of these, you even get to the point that you have life, we care about, well, do you get intelligent life? So maybe if the asteroid never hit Earth, the dinosaurs would have stayed on Earth and they would have never evolved to the point of generating radios and TVs and telephones and all the rest. And so it's kind of a freak circumstance that we were, because they were destroyed, these gaps in the ecosystem developed so that we could emerge and be intelligent and do all of these crazy things like make YouTube videos and all the rest. So let's multiply this times the fraction. If you get all of this, the fraction that actually end up having intelligent life. And maybe this fraction is, so intelligent life over here. So intelligent life, this is maybe, I'll throw out a number, 1/10. And probably in the next video, I'll calculate it all. And this is very important to realize, because once again, you could have life. These are all examples of life right over here. This is actually life on our Earth, on our planet, even though this looks quite alien. This is a weevil that kind of looked very close up. But there's all sorts of forms of life, many of which we probably can't even begin to imagine. But what we care is that intelligent life intelligent life starts to emerge on the planet. Because only intelligent life has a chance, we believe, of being able to eventually communicate in ways that are detectable by us. Now, I said intelligent life, but maybe not all intelligent life will eventually get to the technological sophistication where they will be using radio waves and electromagnetic radiation to communicate with each other. Maybe we might have stagnated at this stage if the right things didn't happen. So what we need to do now is multiply this. So right here, we would have the number of planets in our galaxy that have had intelligent life on them at some point in their history. Maybe not at a time that coincides with ours. But what we want to do is whittle it down even more to the percentage that get to the point that they can develop technology that allows us to detect them. So that they're kind of so let me multiply it times the fraction that are, I'll put a C here for, maybe they're using communications, C for communications, that allow us to detect them. So this is detectable, the fraction that are detectable. Detectable. Now you might think that we're done. This would give you the total number of civilizations or life forms in our galaxy, or the planets that have life forms that developed detectable technologies at some point in their history. Now, it would be nice if civilizations did not kind of be born and then die, but the reality is they do die. They might destroy themselves or whatever, and they might exist for only a small period of time for the history of that planet or the history of that solar system. So in order to make it the number of civilizations that are in existence now, and I'll clarify what now means in the next video, because it's really, if we're detecting something from a star that's 10,000 light years away, our now means we're just receiving their signals, which means that they released the signals 10,000 years ago. But what I want to do is, what is the fraction of these whose signals are reaching us right now? And here, I'm going to say, well, what's the average lifespan of a civilization? I'll put that L. Who knows what that is? Maybe 10,000 years. So civilization lifespan. And it's going to be that over the life of the star. So that is over, I'll put a T here, T for the star. So the average lifespan for the star. And I could say the average lifespan for the planet or whatever, but we're assuming that if, once our star supernovas, you're not going to have any chance for Earth to develop life on it anymore. So maybe this thing up here is 10,000 years, and this down here is maybe 10 billion years. And if you were to multiply all of this out, you should get the number of detectable civilizations in our galaxy right now. I'll leave you there for this video. In the next video, we'll discuss it a little bit more and reconcile it with the more famous version of Drake's equation. And I'll also try to talk about this piece a little bit, because I think this might be a little bit confusing, and I'll try to diagram that out a little bit more.